Conférence qui aura lieu en anglais, so I will switch in English to address a short introduction. Very welcome, Martin Rauch, tonight for this lecture. It's a big pleasure to have you again here at EPFL in March 2011. We already had a lecture with you, and at the time, most of us were discovering your work and the house you built in Schins, where you live. The house Rauch, that was built with Roger Bolzhauser. It was really an impressive discovery at the time, and now we have followed your work, and you became really a master builder, I would say, in earth construction, round earth construction, a real authority. You develop the technique, and I think also what is very important in your work that you can convince people and you can prove that it's working. We've seen this recently in your contribution to build Ricola building with Herzog and de Meuron, a very large scale building, and you will talk about it later. And you also published, when we did the first lecture with you, you published this book, The House Rauch, I think that we already know. And recently, you published a beautiful book that you can find in the exhibition for people who want to buy it. I think it's sold out, but we still have some copies here that will be on sale after the lecture. And also, I must say that you take a very important part in the teaching this semester at EPFL with Roger Bolzhauser in the studio, participating to the critics, and tomorrow you have a full day of critics. So thank you to take the time for this lecture tonight, and I wish to everybody a very good evening. And after the lecture, we will have a drink down in the exhibition, so we can continue to discuss with you in the exhibition from which you were a contributor and also a contributor to the Pizet tableau that is in front of Archizoom's exhibition space. And this is a work by Martin Rauch that we will have the chance to keep after the exhibition as well. So thank you and good evening.
Yeah, thank you very much for the invitation, and I'm glad to stay here and to make this lecture. I'm sorry for my English, and I'm sorry that I cannot speak French, but I hope the work and the picture will say a lot. First, I have chosen this picture. It is a landscape, and the erosion all over the world is the part for the clay, because clay, argil or earth for building, it is eroded material with water, wind, earthquakes, like this. And if this eroded material comes down from the mountain, and you take it and mix it with water, put in a shattering, build a house, and it is a healthy, good house. And if it's not used, if there is no roof, then it can go back into the landscape, and it has no pollution. This is a very short circle, and for me it is a very fantastic way, building with the earth, living in there and go back. And all over the world, earth construction is a usual construction system. Also in Europe, in every country. And if you go over the world, then there is, from the different climate, the different material, so the forms gives their forms. And for example, this is in North Cameroon. It's very hot. There is a high, like a pot, 4 or 5 meter high, and it's a really good climate. And the pattern, if you look, this is a pattern. It is like for the erosion, because if the water runs down, It is like if sand were raining down, this is the pattern. And the pattern is also the scaffolding. So for me, it is very fantastic because the pattern has some reason about the earth, the raining, and also to bring up every 5 years, they bring up a new layer of earth. It goes down. And also this house is for me a very fantastic house. It is a house in Arabic Arabic land, and it is built only by hand with no tools. Only the earth, you make a hole, put in water, ram it, and take this and throw it up. It takes, it names Zabur technique. It is all over the world. In Africa, they make it like this, and it is very usual that the corner go up. They make more stabilized, and that is that the builder can make a sharp wall. Or if the windows from inside, it is very covered with very fine white clay and lime, and it comes out. And look at this pattern here. This is not like a pattern because it is nice, because they had no bitumen, they had no iron sheets or like this. And if it's raining, it is the form of the rain, and it comes here up, and here it drops up. There is a calculated erosion. The pattern is coming, and if it eroded a little bit, they go on the roof and they make it always covered if it is new. What I will show with this is a very interesting example for the calculated erosion, to work with the erosion. And that the earth construction is really has enough experience all over the world. There are 8-story high buildings, and the static system is like a tree, thick walls and go up very more thin, and it is really interesting building. Or this is in Shibam in Yemen. It is a town with about 200 towers. The towers go up like fingers, and the fingers gives the shadow. So in the streets, in the small streets, there is more cool. So it is like a climate system, but the buildings about 300-500 years. But the earth, if they break down and they build it new, the earth, if with this, they have built these towers, they are more than 1,000 years old. It shows that if the tower goes down, they build with the same material again. This tower is always built with the same material 5, 4, 6 times once more. It shows the earth construction. If it's not stabilized, it is always you can recycle every time. Now I come to my work. I was, since 35 years I work with earth construction, and I was coming as an artist to the earth construction. And in 1999, there was a competition for artwork in a hospital in Austria, as in my country. There was 108 long wall, and as an artist, you can make a painting or you can make some stones and so on. And I said, there is a huge glass house, and it would be nice earth. And so I say I make a earth construction. I won this competition, and my problem was to realize this, because this wall was a artwork. Nobody asked me about the static system. Nobody asked me how you will do it. Because if you are a painter, they make a painting. And if I start there and come with a big machinery, and we moved 250 tons material. There was a building, but it was just unworking. And then I realized it, and everyone can touch it, and it is hard, it is strong, and it works very well. And so with this material you can build. And so the buildings start from step to step. I realized always more bigger projects, and now I show you some projects where they was very important. So one project was the Versöhnungskirche in Berlin. There was a church with Reitermann and Sassenroth. It was first planned in concrete, but the client, the church, they don't like concrete because the project was in the middle of the Berlin Wall, and they want no statement with concrete on the Berlin Wall, and they wanted to make it in earth or wood and like this, and there was a big fight between architect and client. And in this part, I was coming to them and said, and they have seen then the wall in the hospital, and and we said, okay, we can realize it in earth construction, in rammed earth, and then the architecture was like it, because earth construction is nearly like concrete construction. You have a shattering, and you put in earth, and it gets hard. And so it is a very good comment, as a good connection. And then there was the big problem, the static problem. Concrete, you can make walls and you can put the roof. And they said, oh, in earth construction it is not allowed. And in Germany it is much more not allowed. And then we tried to get in 6 months the Zustimmung im Einzelfall. That means I don't want to make columns with wood. If we make it in earth, I wanted to make in earth and load period, like all the walls and all the houses all over the world, it would be possible. Why we cannot do it? Because the rule is not like this. Then after 6 months, we get to realize it, and then we make a shattering. It is 12 meters round, and fill this with earth, layers of layers, rammed with machinery and with pneumatic rammers. And if you remove the shattering, there was always aha. Oh, fine. It looks really nice. You can see all the layer like in the geologic system. And these layers are always some, it shows how the worker has worked. And so 100 layers go up, and only the input of work you can see, you can feel. And I think this is a very important pattern for the earth construction, this input and human work. And yes, and this was then there are a lot of different other project was coming, and the next project what I will show, and it is really a milestone, is our own house with Roger Bolzhauser planned, and we have it was 25 years experience should be realized, like a Selbstversuch, like experience myself, everything. But if I am the co-planning, the contractor and the owner, so I can do it behind, if it's good or not, I can choose myself. Otherwise, you have a lot of discussion. And Roger said, always if said we want to like this, yeah, maybe this would be nice, but it is more work, and but it is so we chose a very good balance of good design, good solution, and we had make a lot of different experience, and I live there myself, and it is wonderful to live in there, and I learn every day. I learn every day in this house, and if I would it once more, build once more, I would not change a lot. It's really perfect, but I would build more consequent, more simple, more simple. Yes, more simple. It is a simple house, but it can be much more simple. And it is a rammed earth house, and I was very glad that I can use the excavation from the house with 100%. And it was for me also, you remember the Arabian house. I want to see that from outside you should see that it is a earth house. And the earth house and with the calculated erosion, but the earth can erode it like a rock, like in the landscape. So the house is 3-story high. It is the walls are 45 centimeters thick in earth construction, in earth rammed, and the system is everything what is under the earth. The isolation is outside, and inside you can see the earth construction, the rammed earth. Everything what over the earth construction you can see outside, and inside there is an isolation with reed and plaster, 10 centimeter isolation, and it is 3-story load buried, and also 41% of the volume is under the earth, and also the earth construction goes in until into the ground. There is only protection against water with bitumen. But this 41% of earth is our raw material. We put it out, the excavation. It is a stony clay material. We are separated in a normal machine like this, the normal machine like the gravel. We threw it in, the big stone go away, and this material goes 100% into the shattering, into the wall, and if we don't use it, it can go back. Because in my background I said, the house should be like an African hut, but with a European standard. It should be really built with the material, but it should be not a poor house. It should be really a comfortable, nice house. And the house has a very small footprint. It is only 45 centimeter concrete foundation, very small. That is because it's a very good ground. No iron in there. It is, then we put up the shattering here. You see in this excavation, and this we use the normal concrete shattering, like in the concrete buildings, and put layer on layer, always so 12 centimeter earth from the ground into the shattering, ramming with these rammers. It is a lot of handwork, but it is a slowly growing up of walls. It is it's very nice, and then if you remove the shattering, then it's really fantastic, because this wall is 100% from this excavation. It is a transform from this, the big stone go out and the small stone is there. So it's really 100% this material. So the house grows up slowly, and it is like build a very old house. There is the ceiling are only wood from the side. It is not right one to one. It's the Dippelbaumdecke. It is 1-to-1 lay there, and the most problem was the water, the weather, because we are working about 1 year, and you see we had to protect the walls with sheets, and the water ran down through the house, and this is the most big problem, to cover the wall until the building site from water, because the walls or the earth construction needs a good hut and a good boots. Then it is no problem. And so we have to make the huts and the boots is also a good foundation. And we have tried a lot of different possibility elements. Here the bricklayers, we make it ourselves. Then it is lay with clay and like this, and yes, and also the staircase is in a 3-story house, very important. It is stabilize all the building, and it is 65 centimeter thick, and outside inside is only earth. There is no isolation in there, and the stairs are stands into the earth construction about 30 centimeters. If you go up in the first floor, there inside the walls are white, covered with white clay, because it is isolated inside, and the floor is rammed earth, the same material as the walls, exactly. No mixing, only put the earth into the floor and ram it with like a machine, like an asphalt machine. You ram it and cover this with wax, and it is really good for using. And we make a lot of earth construction, earth floors, only with rammed earth floor. Also the kitchen and the furniture and the doors are wood construction covered with earth and stabilized with casein. Casein is milk protein, and so you can stabilize earth construction with natural chemistry. And casein is a wonderful material. Because it is a very old material. It's a lot of thousands of years. They use it for a glue. The first aeroplanes was glue with casein. It is one of the strongest natural glue. And also I show this picture because you can work in earth construction very exactly. I think more exactly as in concrete, because you can put together, and here to connect it, the joints, you take sheep wool, put it in clay, put it like this, and put it in there, and it gets hard, and it is like a little bit elastic. That is, you can make a wonderful connection between wood and clay, because the earth construction is more dry as the wood construction. So if there's some water come in, the water dries out over the earth and not over the wood. And so it is the reason, because all over the world the Fachwerkstechnik are working in connection with wood and earth. So we can learn a lot of the old material, of the old techniques, and we can use it in a very simple way again. Now I come to the calculated erosion. Calculated erosion is for me a very important part in a future Earth architecture system. Because we can, if we make it in a very good mix, ram it, and if there is some brick layers or some other stuff, it is like protection again. The water doesn't run too fast down. And here in the house, we had make it like with wood, and the brick layers stand up about 2 centimeters. And you see here, 2008, at the beginning, it was very smooth. You don't see it. After 4 years, the surface was washing out a little bit. As the fine material washed down, and the stone comes up, and the stone stabilizes the earth. It is like in a canyon. If in the canyon there is a stone there is really a tower. Because if it has a roof, and the water gets down, and if there is raining there, the earth gets a little bit bigger, and the water doesn't go deep into the wall. Because the water, the wall is more dry as if it is concrete, rammed concrete. If it's rammed concrete, then the capillary system, the water goes deeper into the wall. And you see, if the water is eroded down, and if there is a small crack, the dirty water goes into the crack, and the crack closes it. It is really fantastic. And then you go down, and then here the erosion stopped, because here the energy is, this is only a speed breaker. It is no roof. It is a speed breaker, and you see down. If it's, I have made this photo after a very strong rain. It comes down, and the earth is laying up here. Here it goes up. Here is eroded, and here is sedimented. So it is the system. The earth can, the earth construction or the wall get more rough. Or like if you make a wood construction, and the wood you let it get it gray. So it is like in the earth construction, you let it make it's more rough. And this in other project you can, if you don't like bricks, then we make like plaster myrtle, also that's in the shattering. So it is lime plaster. And you see this granulat from these stones, and then this can wash out. And this is at the beginning, and then it is washed down a little bit, and the system gets always more rough. The problem is the psychological system, because we don't like the erosion at the house. So we are afraid. We are very afraid if the water washes down the earth. We have to learn it. We have to design with this, that let it do. Then it can really work all for future. And this erosion is not, if a lot of people make the question or ask me how long it needs, how many years it needs that the house go down. And if you have 70 years, and you say in these 70 years, this is about 70 years, then it is not like linear like this. At the first, it comes a lot, and then it goes always slowly, 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 and very, very less. And you know, the old buildings in Lyon and everywhere, they are 150 years. They are standing well because the erosion has started, and then it is very less erosion. And we have to learn about this. For example, 2019, I make a Duscher house in Basel, in Basel Zoo. There it was a problem, a mistake from the roof. A lot of water is running down here. And you see it was washing out, also like here. But the client doesn't say we should repair it, because he likes it. So it is no problem if it is a kind of natural structure. So if it's really a good material, then it is like if the wood construction get old or like this. So it would be very easy to cover it with the same material and you don't see it. Also it is possible to repair it very much. So it is about now 17 years, this house, and we had nothing done, some maintenance, no maintenance until now. And I say that we are really build good earth houses. They are not a soft house. It is real houses with very less maintenance. It's too loud?
No, it's just making echoes.
Okay. Yes, now the inside there is a two-story working space. You see the material. It is you can work very fine, and also the earth floor. In the bathroom, the earth floor is not useful. There, it's better you use tiles or truss calc or like others material. And here we have used Karak tiles from my wife and my son. They make it themselves in the oven. It goes out, and then the reduction in the wood dust, and it is a reaction between fire, air, and water, and it is a very interesting element. You can find this on the Karak. What I will show you is there we had also the house Rauch. We had make research work with from the School of Lucerne, and they have, you see here, this is in the summer week, 1 week. The green one is the humidity outside, and the red one is the humidity in the room from a conventional house with concrete and gips plaster and the blue one is the earth house. And what you see here, that the earth make the balance. It makes balance between 40 and 60%, also in 50%. And I also in my house in the summertime, you see it is really, you can really feel the good climate. In winter, there is not so much different because there is heating. So you have the same, but in summer, there is a very important to use clay, and it is a good example to build all over the world in hot countries with earth construction. Also, the premier energy is less, more as 40% if you build with earth construction. Now, in this year, we had make earth for Bishop's Grab. It is in a church, like a grooved. And it was interesting because it was, we dig out the earth from the church, about 4 or 5 meters deep, and put in a shattering and ramped up 28 I don't know the English word, grooves, and it is really interesting because everything is in the earth, also the roof we make in earth, the floor, and it is, you go down into the earth. It is an example to use really in a big scale earth construction. Another part is the cinema in Ilanz. It is a restoration of a cinema. Inside, it is a small group of 50 people. They wanted to make earth construction. It was really expensive, so they said, we as a company, we help them for half how to do it. We give them the shuttering, and then they have built everything alone. So it is a good example if if in a group you can motivate very well people to build in earth construction, and they have really months, 2-3 months, they have ramped themselves every weekend, and they had really a lot of fun if it was finished. And the earth construction is also a good part to participation with the people. Then another solution, there is a renovation of a stable in Almens. There is a 300-year-old stable. They have put everything inside out, and we have built in the middle 3 stories earth elements. These are earth elements 7 meters long, 7 tons. Let it down 3 stories, then put it over there only with earth, and in there is about over 100-meter earth pipes for activated for the solar energy, and then you can ramp up, and you see the joints. You don't see it again, because the change you can also, here is a connection, and you can remove it, or also you can. This is the oven and the chimney. You can really work very precise, and a lot of different construction. So it is also load period. And yeah, now I come to the Ricola building. With Herzog de Meuron, I have worked 2000 for the Schaulager. There was a study to the Schaulager in Basel should be in earth construction, 22 meters high and 250 meters long, the round element. And but 2000, the client was too afraid to realize it, and it was not coming. 10 years later, they remember about this study, and then they had in Ricola this building, and the time was coming that they said, oh, yes, for this building, ramped earth can be possible. And so we have started to sub-planning for the facade. You see here is the building. It is 110 meters long, 30 meters wide, and 11 meters high. It is in the field like an earth block. And the construction is a concrete framework, and the earth construction is like a close outside goes over there. You see here is the columns, and 45 centimeters, 12 meters high are the walls. And it is about 3,500 quadrat meters. And here was here is the storage. And this is not heated, so this is also also for climate. Also that's because we have to look that it is not less 5 degrees and not more as 28 degrees, but more important is the humidity, and it should be not be 45-55%. And the clay or the earth construction can do this. This is like a machinery, the earth construction. And here are the machineries, and here are the entrance of the material. Here is the storage, and so like this. You see, outside it is the calculated erosion I have explained before, nothing else. Everything is not stabilized. And inside, we had at the beginning a big problem for the farmer, for the Swiss medic, because they make medicine. So we had to get a certification that the surface is not dirty. So because they said that the first, Earth, it's not possible. We have to cover it with plaster and so. Then I asked, why is possible the concrete? Because the concrete is very smooth. There is no holes for some animals or like this. Oh, then said we can do it also. You have the rough structure we have covered with a very fine layer of earth. So it is really very fine, and it is now certified for Swiss medic. Yes, the material we have in a circle of 8 kilometers. We have find all the material for this building. Here some gravel, here some excavation, and here the argile or clay, and here is the building, and here is the production. So very less transportation. We put all the material to the production site. We make there in a prefabricated elements, 670 pieces, and then transport it 3 kilometers to the building. And this was the excavation of the clay. This is the excavation. And this is the excavation. This is gravel with dirt and clay. It is the gravel. Nobody wants to use it because it's too dirty. And this is the best material for rammed earth. So everything what we need is like losing material, but everywhere in the world you can find it. So I say, from every part of the world you can use nearly 50% from the excavation or more until to 100%. Now to realize this, it's not possible to do it all by hand like my house. It would too much cost and too much energy. So old idea to I create a machinery like a plotter. There is the material, it comes out, and then a machine is ramming, and this machine goes like several times there. Then you cut this machine, and for this project, the project was so big that I can build this machine. The machine, this was then the first plans and some experiments. There is a shattering 50 meters long, and the machine is working on this shattering. Then you see it fills up with earth. Then we had, at the beginning, we had rammed a lot now by hand, and then we create some machinery that is ramming themselves, and so we can use to make a long wall, cut it in pieces, then storage for drying. Here is about 450 elements, 4,500 kilo per element. It is normal drying, no energy for drying is there, so it is very economic. Then if it is dry, we put it on containers, transport it to the building. Then we had some lifting system, and build up with clay plaster, block for block, like Lego. So that's big blocks. And then the wonderful solution, the joints we make wet, and we ram this up with hammer. It is a lot of handcraft work, and then you don't see this. Here it is retouched, but here you can see it. So we had 3 months to build up this building. And how it is, if there is a big building, the next building will come, because we get more trust to this material. And I think it is the most important to get more trust to this material, because, and we can get trust if we can touch it, if we can look, and if we believe it is stable. And so we can build really big elements. The next project, what we are doing now, is in Germany, in Darmstadt. It is a building, a bureau building for 450 people are working in there. It is the headquarters of Alnatura, and it is, the idea is so 12-meter high walls, 28 elements, and between is the glass. And what here is new, because in Germany we have a lot of very high regulation about the isolation, and we had built 2 layers as of 12 meters high, and so 2 layers with the isolation inside. You see here, it is 38 centimeters earth construction, then Misopor, glass Schaum, also rammed glass Schaum for isolation, and inside 40 centimeter earth construction with a layer of pipes for heating and cooling. And it is very important, because earth construction is very expensive. But if you can do it a lot, if it is an element for isolation, it is an element for heating, and it is inside you can see it, outside you can see it, so it can really work. And so we developed a machinery. There, it's like the plotter before. There we lay it inside. There is earth. In the middle is the Misopor. And there is the different elements. The material come in here. Here is the filling system, ramming system, second ramming, and cutting system. So it is really a machinery, and it is not one time. It was from every project we have additional one element to make it better, and it can be much more automatical, but it is not necessary, because in the moment it works very well. 3 people have to work with the machine, and then here is the ramming element, then the ramming machine. These are 3 rammers. They go automatical like this, and if the shattering is full up, then we open the shattering, and we are work a lot of machinery, but I show this this picture because the people are always most important, because you cannot do everything with machine, but the human work is really very important. But the heavy work is necessary to make it with machinery. Then the element will cut, then you put it out, then we are testing the pipes and so like. Then we let it for drying, about 380 pieces, and then it comes to the building site. There is it is parallel to the contractor. We put up the earth construction, 1, 2, also 12 pieces over there. Then we have make how to fix it, because there is no reinforcement iron or like inside. It is nothing inside. And then you put the clay plaster there, lay the element on there. It is balloon on the clay plaster, and then you can fix it. And now it is 1, 2, 3, 4, 5, 6, and it comes now once more 6 elements go up there. Yes, this is still working now, and it will be finished in end of this year. And now I will show you a project in Tessin. We have made it about for 5 years, or 7 years maybe. It is a school with rammed earth, and you see here the calculated erosion. So the facade stands themselves before the elements for the building, and I show you, and that's the possibility that you can really create a lot of different parts in earth construction. Or here the Vogelwarte in Sempach. It is also in prefabricated elements in a big scale. You see, there is not the brick layers, there is layers with plaster, and the windows are very small because of the static system. That's like this. Now I come to Saudi Arabia, and I show this picture because it is the Palace of the King. It was built 1936 for about 8 years, all in earth, a wonderful building, climate very good. And today the situation is like this. In the 70 years, the earth, the oil come out themselves, and they have destroyed all the towns and built this kind of construction, global construction, use energy in a very terrible way. And we are worked there since 5 years with Noheta. It is an architecture bureau in Norway. They had won a competition for Aramco, a culture center. At the first hole where the 1936 the oil was coming out. So it was exactly on here. The oil was coming out, and there is a culture, and the idea was everything what is under there should be in earth construction, and that is for the culture, because in Saudi Arabia a lot of earth construction was done before. And this is now the building. Outside it is a facade with a lot of pipes, also with pipes. And here inside is a lot of earth. I think it is the biggest earth construction what we have done, also from the volume. It is 12 meters high and about 120, 80 meters long, and it was only possible to make it in prefabrication. And because the building was finished and we have to install it inside the building, so we make lines, all the pieces, how we can do it. We make a art design that it looks like geologic lines. Then, and then we realized these elements, and this is a connection between the facade and the earth construction. And it was really interesting to do it. It was, the difference was not to do the earth. The problem was to do it in this big scale. So we had to create it with the company there, 85-meter long shattering. And we could not put the machinery like we had in Basel or in Germany or like this to there. We put some wood bottics like this, and 14, 15 people who put the material in, and then they ram it by hand, and then they put it inside. And the human work was 150 people. They was quicker as the machinery. And then it's the same system. So we had to cut this then to put it out, let it dry, and then to fix it in the building. So over 1,500 elements was fixed in 4 months. You see the layers of the pattern, also that, and until 112 meter high. It was really a difficult way, but this was no problem for do it. And if it's very important for us to work with the worker, and if we had finished and we had make a big party, and they are really they like it very much. And this was the guys from my company. They stayed there for 6 and 8 months, so they have really worked with the people, and that was very important to work and to show and to give the know-how. And it is the guarantee for a good work, that the people like to work with this. And we have a lot of different projects, like here in building in Tiflis, or there is the embassy of Germany should be in Earth, and how I will show you how we will get the material. We always try to use the local material. The first I go to Google Earth and I see here is the building place, and here are the quarries, and then we said go there, and then we go to the quarries or to the big buildings, the material, or the excavation on the side. We look for pictures, and then we see, okay, this material can, I think it looks like that you can use it for rammed earth. Then we go there, we go to a plant, a brick plant, or on the side we look, drive around. Then we make some samples, maybe 4 recipes, bring it to Austria and make then some crash tests, and so we can look. And mostly it is the problem is not the material. The problem is that they don't believe that we can only use this earth, also without additional of cement or some additives. Only the different earths in a right mix, you can ram it, and then you make it. This was in Saudi Arabia. You make the first mock-up. They come look and what's happened, because it is a 4,000-year-old technique, but we don't believe it, that it's only so simple. It cannot be so simple. Only take earth, stone, ram it, and finished. It is too simple. Then they look, and then we have to put some crash tests. And if we bring some paper with a lot of numbers, nobody understands the numbers, but it gives more trust. So it's really, it is a funny situation. But all the project gets bigger, and I think the administration and the norms get much more difficult. I think in Ricola it was very easy. I'm happy in Switzerland you need only a sign from the engineer that it is working, and it costs nothing. But in Germany, or example, this was the idea. Example, we had to fix the roof there, and then the engineer said we should hold about this screws should take 340 kilos. Okay, we said we make an example. We put a hole, put like this, and we put a simple there, and it was not 340 kilo, it was 1,950 kilo. So okay, it's finished. It was a very simple test. But in Germany we have a lot of tests to get Zulassung Einzelfall, and what we have done in Ricola, nearly with very simple way. In Germany it costs 150,000 euros. That's really crazy. So the problem is, on the one side, they like norms. On the other side, the norms stops the innovation. Because if I have idea and I cannot do it because I have no norms, then it is a big problem. Norms, I think in the last years I have a lot of problems with administration, and it costs a lot more. Before 10 years, I could build it. I built it. I have done it. Today it is not possible anymore. And that is a little bit a problem. And we make a lot of examples every day. We should rain tests, how much water can go in. We have developed a lot of material tests, and some are working, some are not working, some cost only a lot of money. But then we make tests of material, and we make a lot of research work in the building, and always a little bit too late, and not before, after, during the building. This I have put this picture because this wall is here in Genf. I have make it with architect here in Genf, and it was too far away to bring the material to here. So we make a hole, put the material to here. Then I say, okay, we need a little bit gravel. We put some gravel, mix it there, and fill up into the shattering. So with a local material, you can work very easy with the local material. Yeah, I think it is long time now. I have now. What I want to show is the Kuppel in Zurich. I will show it is a good example to work with students together. It is in ETH with Annette Spiro and Salis. It was experience with students. 14 students has developed like a pavilion, and after the curricular building, I have given them the space for 14 days. They have, in this shattering, they have make the elements prefabricated. Also these blocks. ETH, they have make some crash tests because it is a little bit a static, delicate situation. So how much big has to be these columns. So then the rough material is rammed to show them. This is the arches. They was then turned 90 degrees. Here the arches, and then you set up this. And you see the joints, you can close it, and it's really a nice situation. Or mudworks in Harvard, we had with Anna Heringer together, we make some, we say it is acupuncture points. But sometimes it is important not to build a big building. Sometimes it needs only like a building together with students. And there are 150 students have worked about 10 days with 50 tons material. And it is like an input, and there was a lot of discussion, lot of testing, and it changed a little bit. And I think this is a very important point, and it's also very important that in the university the students work with earth construction to have a feeling to this material, to think about this. And maybe one or the other will change their mind and will build in this situation. And I think there is also it is very important to build good and nice buildings, and nice to work with them, to get trust to this material, to get knowledge to work with them, to get a feeling for this material, because we have forgot to work with earth. We are really, the farmers doesn't work really with the earth. We should get more feeling for this material. So I think the last project is also in a bureau building for a high-tech space. About for 350 people are living there, and the client Omicron has give us and some hotspots to create a room where the people are stay all the day on the bureau building, to go here to relax, to drink coffee, to speak, to I say anti-stress room or like this. And we have and this company also bring 10% of the profit for creative project in all over the world. So we create a earth house, like you remember the first building from Cameroon. It should be and pot only built with clay, load buried, a simple way, but in another form, in a modern building, and like this. But it was not so easy, I thought. We had to make a digital model to calculate the structure engineer, and at least it was very complicated, because it goes in, and at least the computer cannot do it real. And at least we had to make it only one part. The other one part we allowed to build ourselves. We build up like a pot, and I say Gefühlsstatik. And at least we put it in 3,000 kilo sandbags and let it one night, and then it was done. Also it was certificated. So it was the inside, this is covering, and all that's, it's a very small room. And also the space is earth and casein, and with wax protected, with acoustic clay plaster, and for sitting like this. And the monolith, the outside is only polished with a very fine clay, with a lot of children of the people who are working there, from the families. It is not allowed that children can work on the building site, but here we can do it only on Sunday and Saturday. But so we was 80 kvadratmeter, polished very fine, and it's really very interesting surface. So it is this all polished by hand, and they like it very much. And because the people, the families has worked themselves, so they have a more identification to this material. And in Biennale, we had make a simple, nearly the same place. And what you have said, I bring this element here in this, the rammed earth picture is here on the side. This is my last picture, new, modern. The way is long, and I think it is very important that we develop the earth construction in a modern way, and there is really a lot of possibility that you can find new solution, new architecture design, and I think it needs 3 generations. Good workers, they like to work with this material, and that's very important, and that the children can get connected to this material, because it takes 2 or 3 generations, then really it can change a lot. Thank you very much.